Welcome everyone to our YouTube channel. First of all, what a happy weekend it is. It was India-Pakistan very beautiful match and we have won the match. Okay, now it's important to absolve the today Leetcode contest. So we are going to absolve it. So let's start with this. So our first question is to determine if two events have conflict or not. So I think the question itself is describing so much. So let me read question once more. Question is saying that you are given two arrays of string that represent two inclusive events. Point, point note this that two inclusive events that happen on the same day, it is on the same day. Event 1 and event 2. Now we have something called event 1 starting, event 1 timeline and event 2 timeline also. Event times are valid 24-hour format, hour and minutes. Okay. What is conflict? Now conflict is a conflict is when two events have same non-empty intersection. Okay, that means some moment is common to both events. If there is conflict, return true, otherwise return false. So let me understand it with an example. Suppose there was T20 World Cup is going on right now. Okay, so suppose in today it was India versus Pakistan at 1:30 p.m. and it's end at 7 p.m. Okay, suppose that now if let's suppose same day New Zealand versus Afghanistan. Suppose this match is also start at 9:30 and it will end on 5 p.m. somewhere 5 p.m. Okay. So now it is a purely moment of conflict. How conflict? Because a match is starting before one match and ending after starting of another match. So there is a conflict. This is the conflict between two match. This is the conflict between two match. Now thing is that how can I think you understand it what is conflict? How to build the logic to solve this problem. Okay, first of all I have to erase all this. What things we have given? First of all, the question has given to us is four variables, and that four variable is suppose starting time of first match, first event or match. We are supposing it's a match. Ending time of first match, starting time of second match, or and ending time of second match. Okay, this one has given to us. Now they are asking if there is conflict between these two or not. So when is the conflict occurring? So first case of conflict is whenever the second match is ending. First match is ending after starting of second match. So if I draw a number line properly for this case of conflicting, if I draw a number line, so case of conflicting. Okay. First case of conflicting is suppose the start of first match is happening here and end of first match is happening here. Now in between, if a match starts, second match start, there is a purely chance of conflict, right or not? Yeah, it is a pure chance of conflict. So case one is what is the case one? Case one is ending time of first is ending time of first is greater than greater than equals to starting time of two. This case is clear. Okay, now it could happen that it was started not here, somewhere somewhere this side, starting of two. Now our condition is true and ending here. Suppose ending of second match is here. Now in according to our condition, ending of 1 is greater than equal to starting of 2. So it should return true, but if there is no conflict. So we have to also check. What we have to check this ending time of second. Ending time of second is greater than of starting of first, because there is no chance of conflict. In this case, the conflict only happen when ending time of second match happens to be here or here, somewhat after this starting of first match. So second case is ending of second should be greater than equals to starting of one. Both of the case simultaneously have to be satisfied. Both of the case have to be simultaneously satisfied. Then there is a chance of conflict, otherwise there is no chance of conflict. Okay, so now logic is understood. Let's go move to the code. So I have pre-written the codes here. It is not my code, it is I have actually taken from the lead 215. He's a lead coder, good lead coder. So take a look at his code. So what is this compared to? First of all, let's understand what is compared to function in Java. So compare to function, suppose I have a string 1 and there is string 2. If I am comparing these two string with the function compared to, then if s1 dot compare to function is there and there is something this, if this is returning greater than 0, this means s1 is greater than s2. If s1 is less than s2, then it will return negative value, and if both are equal, then it will return 0. This is the compare to function doing in Java. So what we have done is, let me write it, starting of first match compare to ending of second match. Let me erase this. Starting of first match dot compare to ending of second match. So now check. According to our logic, starting of first match should be less than equals to ending of second match. Starting of first match should be less than starting of first match is less than equals to ending of second match. So this will have to return negative value, less than or equals to 0. Or or what was our second condition? Our second condition is ending of first match should be greater than uh, starting of second match. So ending of sec sorry first match ending of first match dot compare to starting of second match. Now what should this will return? First string is greater than, so it should return greater than equals to 0. Both of the condition will satisfy, then only we will return true, otherwise we will return false. So what we are doing here is same thing, starting of one comparing to ending of second match, and it should return less than 0, and sta- starting of second match ending of second match should be less than equals to ending of first match. So this is the case. Now it's time for second question. Now second question is very simple. It is very simple question I have ever seen in Leetcode content. The question is number of average. We have to find number of average with GCD, with greatest common divisor. What is GCD? GCD is greatest common divisor. We have to find the number of average with greatest common divisor equals to k. So first of all we understand what is GCD. I think you all know what is HCF and LCM and how to find it using any code, any programming language. So I think you know this using Euclidean algorithm. Okay, Also, we have to think what is subarray. A subarray is continuous elements of array present in the array. Like if I take a segment 931, it is continuous and it is a part of array, so it is subarray. But if I take element like 9326, now it is not continuous, so it cannot be subarray. So I think you know what is subarray. If you don't know, you can please check it out on any YouTube channel. You can find about what is subarray. Now we have to find out number of subarrays which GCD equals to K. Now it sounds like something called sliding window. Sliding window. Sliding window. But do we need sliding window in this? Do we need? Let's check the time constant. So our n is 1000. Mention in the lead code that it is 1000. Okay. So if we go to n square, then it's 10 to the 10 to the power 6. And if we know the GCD takes log n, so it will take around 10 to power 6 to find out number of subarray. We all know that we can find number of subarrays in n square. And if you find GCD of all subarrays, then it will take n squared log n. That could be equals to 6 into 10 to the power 6, and it is in the range of the integer. Sorry, it is in the range of time complexity, so we can handle this time complexity, so it is allowed. So we don't go to concept of sliding window. We'll go through the brute force here. And what is brute force? What is the brute force says? What is the logic behind it? So okay, now let's check what is the brute force algorithm we are talking about. Suppose we have a function GCD which is giving the GCD of AB. Suppose there is a function written somewhere which is providing what is GCD of any two number we are passing into it, and it is giving me the answer. Okay, now what we'll do, like we have an array and we have the element HCFK that we have to find out subarray. So what will we do, like we have okay, we'll start from first element. Okay, we will start from first element, then we'll go to the end of the array. We'll iterate over all the element of the array. Now the first element we are getting, so we will store into like current GCD. My current greatest common divisor is nums of I. So my current GCD is nums of I because I am getting the element at ith position. So the GCD of one number is the number itself. Then after I will check if that is equals to K or not. If current GCD equals to K, then we'll increase answer. Suppose I am taking an answer variable to store answer, so I will increase answer plus plus. Okay, then after we will start from, suppose 1 2 3 4, this element at ith position is here, so I will start from ith plus 1 and go till end of the array to find out the sub array start from 1. So for int j equals to I plus 1, I will start from the next element and will go to last element of array. And what will we do? J plus plus. And in that loop, what we'll check now, if there is one case also, if suppose that the array element is less than GCD that we are searching, so this thing is no use, because if a number is less than something, that it could not be the GCD of that number. Sorry, if a number is greater than a something, that it could not be GCD of that number. Okay, now what will we do? It will discard. Like how to discard it? We'll go continue in this loop. Sorry, not continue. What will do? Break, because we are searching in sub array, and if sub array not continuous, then it is not sub array. Then after that, if this condition is failed, then what will we find? That current GCD again will find GCD of what behind this number we have find, like current GCD. Till now, what we have found, and the GCD with current element. So then again, I will check if this is equals to k or not. If this equals to k, I will increase answer plus plus, and at last we will return answer. So this is the logic behind our code. What we'll do, I will iterate over the array. For every element, I will iterate from next element to the last of the array to generate sub array. If any point of the time in I will encounter any element which is less than k, then this could not be the GCD part of the GCD. So I will break from it, because if I continue this array, this loop, that will not part of the sub array. And after that, if this condition fails, then I will calculate GCD till now what we have found, and with that element that we have current, like suppose you have 1 2 3 4, till this I have found some GCD, suppose x, then I will found GCD of x with 3. That's we are doing here. Then after we'll check if the current GCD is equal to k or not. If it is k, then I will increase the answer. After that, all the sub array has been generated and the GCD has been calculated. I will return answer. What is the time complexity of each? Now Euclidean algorithm of GCD takes big of log n. GCD will take log of n, and our subarray generation will take n square. So each for each subarray we are calculating GCD, so it will take n square log n. That is the time complexity for us. Thank. Now it's time to our third question, which is title as minimum cost to make array equal. Minimum cost to make array equal. So before understanding this question, I am actually introducing you to another question which is on Leetcode. So we have an array 1, 2, 3, 4, 5 and 3. In case if you find that if it is not sorted, okay, that is simple this. So I and then idea is, sorry, question is, we can increment either by 1 or decrement by 1. Then find minimum operations to make all element to make all elements equal. What is the question? Like we have all the elements with us and we can increment by 1 or decrement by 1, and we have to find minimum number of operations to make all the element equal. So how can we proceed in this question? Okay, so let's see. You have an array 1 2 3 4 5 and 3. So what we'll do? First, you will sort this array 1 2 3 3 4 5. Now check if you make all element equals to 1, then think about this element. You have to make maximum operation like 5 minus or 4 operation for this element. Okay. Now if you make all element equal to this, then we have to in the increment plus 1 by 4. Okay. So it will cost 4 operation for this element. Now, what if I make someone from middle? Okay, someone from middle. In that case, I have to do same operation for this left side element also and right side element also. So in this case, our operation is minimum. So the idea is to find median. The idea is 1, 2, 3, 3, 4, 5. In this case, I have 6 element. So in that case, the median is these two. So I have to check if with this element and with this element, which element cost minimum for me. And then suppose I have make a element 3, I have a median 3, so I will check with this element like 3 minus 1 2. For this 3 minus 2 equals to 1. For this 0 0. For this again 1 and again 2. So my total operation will cost 2 plus 1 plus 1 2 is equals to 6. That will be operation. That will be the minimum or number of operation we have to make array equal. So now look at our question. What is our question saying? Our question saying we have a nums array with cost array also. Okay. So either we can increase or decrease any element by 1. Same question we have looked upon right now. But there is a cost associating with this on ith element. If I am doing some operation on ith element, it will take cost I. So that's the catch. So what they have added is like I have 1, 2, 3, 3, 4 and 5. Now they have added a cost also like for this 8, for this 10, suppose for this 7, for this 6, 2 and 1. Now what have they done is to associate a cost or also. So take a look. In previous case, we were finding the median 3. So for this case, 3 minus 1 equals to 2. 2 increment operation we have to perform into the cost is equals to 16. So, and in this case, for this element, what we are doing is 3 minus 2 is equals to 1. Then the cost is equals to 10. So it is just like having having 8 ones, 1 2 3 4 5 6 7 8, 8 ones, and we are converting into 3. For this we are converting into 3, we have to increase plus 2, same with plus 2, same with plus 2, same with all. Then this will cost around 2 into 8 16. Same in the case of 2. We have suppose we have 10 2. 1 2 3 4 5 6 7 8 9 10. And for each element we are incrementing by plus 1. So what will they cost? 10, right? Same as here. So this is nothing but the frequency of the element. Now we have an array of elements array of elements with frequency, and we have to find minimum of it. We have to find median of it. That's simple. We have done in 10th. Have remembered it. So what will I do? I will take a low element of 1. Okay, a low variable which is pointing to 1, and a high variable pointing to 10 to the power 6. Now what will I do? I will first take a minimum. Okay, so what will I do? I have a minimum of the array. So what is the case of array minimum? In this case the 1 is minimum and maximum is 5. So what will I do? Take a max element of this array. I will perform binary search upon this. Okay, first of all I will find the mid element of this. Okay, so first of all I will perform binary search on 1 to 5, and the mid element is 1 plus 5 equals to 6 by 2 is equal to 3. This is my 3 is mid. This 3 is my mid element, and then I will perform check the cost to every element converting into 3. Cost of every element converting to 3. Suppose my cost of mid is something called x. Now I what will do? I will check with mid plus 1, like 3 plus 1 is equal to 4. Now I will check with 4. Now suppose this is x1, and also with mid minus 1. 3 minus 1 is equal to 2. Now x2. Suppose the cost associated with x1 is greater than x2. So why will I move into this direction x1? So I will discard this. I will move into this direction. My current minimum is x, and then I will move to this direction. Okay, then I will what will do is I will do high equals to mid. Then I will binary search upon low to mid minus 1. Sorry, mid minus 1. At last, when low and high are equal, we'll exit from the loop and we'll find the answer. Now it's time to code. So let me get to the code first. So this is our code. See what we are doing. First of all, what we are doing, we are taking minimum and maximum from the array. Now while we are traversing from in binary search, what we are doing in traversing from low to high, we are calculating mid there, and then we will check. What we will check? The cost associated with mid. Like for every element to get converted into mid, we are calculating the cost. Now cost is something called res. Now I am checking the left side of cost, left side cost, mid minus 1, then mid plus 1. If left is smaller, then I will move toward left. If right is smaller, I will move toward right. At the last, when the when loop is exited, the minimum element is our answer. Rest is our answer. So see, this is the code will look like for this. We will run it. Thank you.